To the program director, tutors, students, greetings to you all. I am reporting to you a Journal 1 which I titled Silicon Use in New Zealand Horticulture. It is a known fact that insects infestations are limiting crops production worldwide. In the European Union alone, pesticide use massively used in agricultural and horticultural application for approximately 360 million kilograms of pesticides annually, according to the paper presented by Pablo Gonzalez de Santos et al. In 2017. Aside from the economic cost, there is also a huge environmental footprint associated to pesticide use, which are estimated to 10 million annually in the US. So currently, with the issue of climate change and the responsibility to take care of our environment, it is timely to innovate an effective and adaptable management application, which is to lessen the use of pesticides without jeopardizing crops' health and production by using alternative method, making crop production making crops productive and gaining ability to resist to pest attacks. To respond to this perennial problem, I would like to present an innovation that can be easily incorporated and can be easily used and applied in horticulture. And I called it Silicon Fortification of New Zealand Horticulture. Beforehand, silicon is unrecognized what it does to crops growth and its role to pest defense. But lately, it is considered essential and is a so-called functional plant nutrient that enhances resistance to both pests and diseases. Research have shown that silicon application to sugarcane varieties have responded well to resist the stem borer attack, which subsequent studies as well confirm the positive effect of silicon in increasing the resistance to stalk borer. Relating to this novel idea that I have found, and I don't have the personal knowledge and skills, but according to the rate of application that was found to be 10 tons per hectare calcium silicate, there was a reduction of 30% in borer damage and 20% in borer mass in a sugarcane plantation. That most susceptible varieties showed that the highest silicon uptake and the greatest response. In New Zealand, the study of Anderson et al. In 2005, which was presented in Tauranga during the New Zealand and Australia Avocado Growers Conference, stated that silicon has long been associated with disease resistance in plants due to the way in which silicon or silica is deposited in seal walls. It was thought that silicon provided protection against fungal diseases by strengthening seal walls, thus making it more difficult for the fungi to penetrate and colonize the plant. Early studies also showed silica accumulating at sites near pathogen entry points. This observation lead researchers to believe that silicon acting against pathogens by increasing the mechanical resistance of plants. But there are other studies and reasoning. On the reasoning section, I'm talking about that silicon has the unique properties and found that silicon nanoparticles exhibit great potential in agriculture and may work better in alleviating different abiotic stresses than bulk material. Apart from the direct impact of silicon nanoparticles on plant growth and development. Silicon nanoparticles can also be used as nanopesticide, nanoherbicide. So there's a lot of application. And also, it has increasing water retention on soil for soil monitoring, respectively. So, reconstructing all this overall, to reconstruct this, silicon sources for agricultural use range from chemical products to natural minerals to byproducts of steel and iron industries. All these products are shown to be effective in improving crop growth and yield. Slag-based silicate fertilizers are cost-effective, but more attention should be paid to their potential environmental risks, which may arise from the heavy metals contained in the fertilizer. Soluble potassium or sodium silicate are completely water soluble and can be used as foliar fertilizer, but are usually too expensive for soil application. Slow releasing potassium containing or potassium rich silicates that are manufactured using feldspars as raw materials are not only cost effective and agriculturally effective, but also environmentally friendly. With the emphasis these days on environmental and health issues, this innovation of silicon use could be the answer horticulturists are searching for ways to grow healthy crops while still protecting the fragile ecosystems in their own backyards, in our own backyards. Herbicides are massively used all around the world and thus poisoning the environment and largely affecting the biodiversity. Silicon use is the practical element that can be easily incorporated in food production in New Zealand, ladies and gentlemen.